Hello. So today's video is about, wait, it's a bit hot in here. Let me switch on the fan first. Yeah, much better now. Do you know this fan is such a great appliance? I mean, it just rotates and it can turn a hot damp room into a cool, comfortable one. Do you know how does a fan work? It uses a motor for its working. Let's make this video about how does a motor work. Let us understand the very basics of how a motor works by taking the example of this magnetic compass. It is a device used by navigators to know the direction. This compass has a magnetic needle which aligns itself with the magnetic field of the earth, thus telling us the true direction. So, what if I put it near another magnet? Let's find out what happens. Whoa! It's getting deflected. Don't worry, the compass is not ruined and still works fine when I take these magnets away. Now, let's try something else. Look, what's happening? What we saw right now was first discovered by Hans Ørsted, a Danish physicist. In the year 1820, what he found was when he brought a magnetic compass close to a current-carrying conductor, the magnetic needle of the compass deflected. A compass needle only deflects when there is a magnetic field around it, because only a magnetic field can influence a change in direction of the magnetic needle. Does that mean that a current-carrying conductor has a magnetic field of its own? If yes, by applying Newton's third law of motion, which in its most simplest form says that every action has an equal and opposite reaction, does it also mean that the same force will be applied by the magnetic needle on the current-carrying conductor? What instead of a magnetic needle, I have strong stationary magnets and a loosely suspended wire that is carrying current. Would the current carrying conductor deflect because of the magnetic field of its own as well as the magnetic field of the magnets? Well, it does deflect. What we studied right now was the pure science between the interaction of electricity and magnetism. These are not two different things, but they are two sides of the same coin. Can I apply this pure science to create something that has its application in my day-to-day life? A peculiar example of a motor comes to my mind. A motor that is used in fans, toy cars, mixer grinders, blenders, etc. Almost everything that rotates. You know what we define motor as? A device that converts electrical energy to mechanical energy. I always wondered how. Let's deep dive into it to find how does it actually work. The principle of a motor is that of the force on a current carrying conductor due to the magnetic field. Now we have three things over here: the direction of the current, the direction of magnetic field, and the direction of force. It can get a bit tricky to understand which direction is where. So to simplify that, we have Fleming's left hand rule. Fleming's left hand rule says that if you take your thumb, your index finger and your center finger such that they are mutually perpendicular to each other. Okay, thumb, index finger and the center finger of your left hand such that they are mutually perpendicular to each other. Then the thumb would denote the direction of force on the conductor. The index finger would denote the direction of the magnetic field, that is from North Pole to South Pole, and the center finger would denote the direction of current. It can also get a bit tricky to understand which particular finger denotes the direction of which particular aspect. So I have a trick for you guys. Let the thumb be called as father, the index finger be called as mother, and the center finger be called as child. If I take the first letter of those three words, I get F, M and C. F stands for force, M stands for magnetic field, and C stands for current. Hope this trick helps you out. Let us now study how a DC motor works. We have a rectangular coil ABCD placed between the poles of two magnets. The rectangular coil is also mounted on a shaft such that it is free to rotate about its axis. The coil is also connected to a battery so that the current flows in the coil. The current right now flows from battery to A, to B, to C, to D and back to the battery. We have current in the coil. We also have magnetic field due to the permanent magnets. So there would be a force exerted on the coil when there is current passing in the coil. To know the force, we'll apply Fleming's left hand rule. Let's apply it on arm AB. On arm AB, the direction of magnetic field is from left to right. The direction of current is away from us. So the force that would be exerted on arm AB would be in the downwards direction. Similarly, on arm CD, the force would be exerted in the upwards direction because the direction of magnetic field is still from left to right and the direction of current is towards us. So CD goes up. For arms BC and for arms DA, there won't be any force. The reason for that is the direction of current in both the arms is parallel to the direction of magnetic field, and for that reason there is no force exerted on the two arms. The net rotation that would happen for the coil would be in the anti-clockwise direction because AB goes down and CD goes up. After 90 degree of rotation, when AB has reached the bottommost point and CD has reached the topmost point, the arm should stop rotating. But that doesn't happen. The reason for that is due to inertia of motion, AB tries to continue its motion a little further and so does CD. But CD will have the tendency to go to the topmost point and AB would have the tendency to go to the bottommost point. And for that reason, the motor would try to oscillate something like this. Imagine a motor that oscillates. Imagine how your fan would work, how your toy car would work. Would it be of any sense to us? No, right? What we want is that to be a complete rotation. For complete rotation, let's say if I wanted the complete rotation to be in the anti-clockwise direction, I need to make sure that the arm on the left hand side always goes down and the arm on the right hand side always goes up. For that, I need to make sure that the arm that is the left hand side should get current away from us and the arm that is on the right hand side should always get current towards us. For that, we use something called as a split ring. A split ring is basically a ring that is split. Split rings are mounted on the shaft in such a way that when the shaft rotates, the split ring would rotate with it. One arm is attached to one split ring and the other arm is attached to the other split ring. Now, when 90 degree of rotation has happened and arm AB has moved to the right hand side, similarly arm CD which has moved to the left hand side, we can see that the direction of current has now changed. Initially in arm CD, the direction of current was towards us, which is now away from us, and in arm AB, where the direction of current initially was away from us, is now towards us. This change of direction happened because of the split ring. A device which changes the direction of current in a coil is called as a commutator. The battery wire cannot be connected directly to the split ring because if we do that, when the shaft rotates, along with that the split ring would rotate and the battery wires would also rotate. When that happens, the wires would get twisted. To avoid that, we use brushes. The function of a brush is to ensure that the current flows from the brush to the split ring and through them to the coil, thereby maintaining a current supply in the coil. When the coil has turned by 90 degrees, there will be a small jerkiness. To avoid that, we use multiple coils, such that when coil 1 is at 90 degrees, coil 2 would be at 0 degrees. And if I use multiple coils like this at various angles, the jerkiness would reduce significantly. For commercial motors, to increase the power, we have three methods. The first one is that we wound up the coils on a soft iron core. By doing that, we ensure that the soft iron core also gets magnetized. This helps in increasing the strength of the magnetic field. The second method is by using electromagnets instead of permanent magnets. And the third method is by using multiple number of coils of copper wire. And that is how a DC motor works. For the intuitive ones amongst you, I have a question for you. For a motor, I provided current and magnetic field and a force was exerted on the coil. What if I provided the force and the magnetic field? Would I be able to generate current? Think about it.